Hello, everybody. Can you hear me? Hi, Dave. Hi, Leo. Hi, Amar. Hi, Mohammed. Can you guys hear me? Cool. So, great. So let's get started. I did not receive any questions this week. So what I'm going to do is I'm going to go through a list of potential projects. So if you, hi Bang. So if you, if you have not decided on the project yet, you can select from one of these projects that I discussed today. And most of these projects that I discussed, depending on how you implement it, they should be implementable in about 40 hours. So here are some project ideas. So the very first idea is Snapchat filters in 3D. Although it sounds more complicated, but if you just want to build one filter in 3D, it's not very difficult. What you need to do is use two different concepts that we have taught in the course. One is simple warping, and the other one is the pose estimation. So what you need to do is you need to have a texture map. A texture map is something that you're going to overlay on the face, but in 3D. So this texture map, and you need to have the points for the texture map in 3D. Okay, so you have, for example, a mask, and you have some triangulation on the mask, but it is in 3D. So you have 3D points for the mask that you want to put, and there is a triangulation in 3D that you have defined. And for this mask, you also have the texture, the image that goes on it. And what you need to do is, if you look at the code for pose estimation, the way I'm projecting the point on the nose, you need to project all these points onto the image plane, taking into account the pose of the face. So once you project all the 3D points onto the face, after that you can project, so you know what triangles got mapped, what 3D triangles got mapped to what 2D triangles, and then it is the same as warping 2D triangles. So so that's an interesting idea if you want to make 3D texture map Snapchat filters. It's a very good option to try. The second project idea is Sudoku solver, and there is code available online. I would like you not to use any of that code. Sudoku solver has two different things that you need to account for. First of all, if you don't know about the game Sudoku, you should go and check it out. It is SU DOKU, Sudoku. It is a simple, it's a game in which there are numbers on a grid, and then there are some rules like each block needs to add up to a certain number and things like that. So there are certain math rules that the game needs to follow. So the challenge there is that you take a picture of a Sudoku in a newspaper or in something, and then you first find the Sudoku, where the Sudoku is located in that paper or newspaper. You extract it and you put it in a format that can be used. You rectify it. You change from the image. It needs to modify so that it's rectangular or it's a square, and then you have to apply digit recognition on top of it to figure out what digits are there in which hole in the Sudoku, in each cell in the Sudoku. So Sudoku has these cells. It's a square game with some numbers and some holes. So you need to figure out what number is there in each cell, and then you need to figure out which cells are empty and how to fill them. So Sudoku solver is, again, I think a neat application that you can build. There is some code available online. Please don't use that code. Try it completely by yourself. Now, the third one is a virtual keyboard. So there are a lot of things that you can do to make things simpler in case of a virtual keyboard. So virtual keyboard is essentially on the screen, we will overlay a virtual keyboard. Like on the screen, you would see the keyboard on top, and the user can go and tap the keys to write something. Now, it's actually not very easy if there is a lot of distraction, but what you could ask the user is to step back, so that the keyboard is on top, and the keyboard is not the keyboard is on top, and it is not the top of the screen is completely undistracted. It just has your hand like that, and you could actually make a keyboard, virtual keyboard. Hi, Steven. Hi, Warden. So virtual keyboard is one other application that you can build. And then you have to do some skin detection. Maybe you don't even need to do skin detection. You can actually do simple background subtraction to figure out that a key is being pressed. So that's one application. Now, I also like this application of Virtual Makeover. My company did this, but what we did was for photos, you can, with today's technology, you can easily do virtual makeup in videos. And you can pick up a few makeup products if you're interested. You could say that I'm just going to do two, say lipsticks and eyeshadows, and you figure out how to do lipsticks and eyeshadows. Now, there are a few different things that you need to keep into account here. First of all, when we run the landmark detector, we only get points. From points, we need to find contours. And you can use some kind of a spline to connect those points so that it looks like a continuous spline. You don't need to do very accurate edge detection or anything for the lips. You could just join those points using a spline, and it would look okay. It would not look very bad. In addition to that, you also need to come up with a rendering algorithm that looks good. So for example, if you want to render lipstick, if you just put in the color and overlay, that's going to look terrible. It's not a simple alpha mask. It's going to look terrible. It's not going to look realistic at all. So to do nice color rendering, you need to be at least, in HSV space. There are other techniques people can use, but at least it should actually, the lighting has to be preserved. So it has to be done in some kind of light preserving space. So when you transform colors to the HSV space, all the shading information, how the lighting is being affecting the scene, that is in the values dimension, the third dimension. So hue, saturation, and value. So don't modify that value. If you don't modify that value and only modify the hue and saturation, that way you will be able to change the colors, but the shading will remain constant. So it would not look like you have overlaid something on the image. So it's very important that you preserve the shading for any virtual makeup application. And for that, HSV color space is a good one to use. Yes, so that's very interesting. Lipstick can have a little bit of shade, and you can actually simulate shine on the lipstick by something like a Phong shader. You could do that. In fact, we did something very similar in our own application in my previous company. But you can fake the shine in so many different ways, because shine is a simple addition to the underlying shading. You can actually have a fixed pattern for the shine as well, and then add that fixed pattern in some interesting ways. You could, yes. So Scott, you can use a Phong shader to do that. You could use something like a Phong shader, but you don't have the parameters, right? You don't know the surface normals at every point. So you have to come up with a guess for the surface normals based on the shading, the hue saturation value, the value of, the third dimension of HSV, Based on that, you have to come up with an estimate for the surface normal. Even if you cannot find an estimate of the surface normal, you have to find an estimate of the cosine theta of the surface normal and the light source. And then you can use something like a Phong shader. I cannot reveal much about this because this is work that I had done for my previous company. But yes, you're on the right path. Okay, so that's that. Yeah, so Scott, just to answer your question, what we need to do is we need to find the contour of the face, the contour of the lips to apply lipstick. So we need to find the contour of the outer lips, subtract the contour of the inner lips, and then we have this lip region, and we need to color only this lip region. And the way to find the contours is, one of the ways is that you can actually join these lines using smooth splines, smooth 2D splines. And that would give a reasonable, it would look reasonably well, right? You don't need to go to a pixel level segmentation of the lips. Just using splines would do reasonable results. Scott, that will work also. If you create a warping grid to the mouth points, that will work as well. At least for gloss, you can put a very high gloss and then do some kind of blending. There is some kind of a hack that you will need to do, some kind of blending so that it doesn't look unnatural. Okay, moving on. And so this next idea was something that Vikas suggested me. And the idea is very nice, actually. So you can have a camera looking down on a table, and you put one item of food, right? To make things simple, let's just say that you have, a few 10 items of food, potatoes, rice, a few different things. And you put that on a table, and it will tell you the calorie content of the food. Now, of course, there is a challenge. You don't know. In an image, the scale is missing. So you may not know exactly how much material is there. And also the depth is missing. So what you could do is put this, instead of putting it on a table, you can actually put this on a scale. So you have a camera looking down at the food and also at the scale. So you can read what the scale says and then figure out what the object is, what food item is there on the scale. So you can read the scale reading as well as what's there on the scale. And based on that, you can come up with a calorie estimate. I think it's very doable. No, you don't even need a stereo camera. I don't think you need a stereo camera. And stereo camera is not going to help because suppose you're putting in rice. So rice has depth that the stereo camera cannot see. Stereo only works when you can see it from two different viewpoints. But yeah, so in case of rice, things are occluded. They are beneath the surface, and there is no way to get the depth unless you're using a second camera from the side, which is all very cumbersome. I think the easiest way to do it for this project would be that you put this for this course, because you need to do this in 40, 50 hours, is you put it on a scale and you read the scale reading directly, a digital scale of some kind, and you read the reading directly, and you find out, and it becomes a classification problem for the food item. Let's say you say that you're going to recognize only 15 or 10 food items, and say like potatoes or rice and meat or whatever, and then it's a recognition problem. First you need to do image classification, and the other problem is text reading, right? And you can use off-the-shelf things like Tesseract for text reading. So yeah, Scott, that's tough. Okay, now so that was one idea. Another idea is that Vikas suggested was distracted driver. So based on how the driver is interacting with the passenger, or they are looking on the side, um, it will actually, you can actually figure out whether they are distracted or not. And the nice thing about this problem is that there is a Kaggle competition that is for distracted driver, which means that they also have the data that you need to do this project. And if the project goes really well, you get to participate in the competition as well, the Kaggle competition. So it's like firing, killing two birds with a single stone. Yeah, Amar, that will also work if you can put some kind of weight sensor and integrate it in the same application. So yeah, so distracted driver is something that you should look up on Kaggle. They have a competition going on. Then the eighth idea is liveness detection. And this actually has a lot of commercial potential. Now, liveness is a very simple idea. The problem statement is very simple. In case of face recognition, you do not know whether the person is live or you're looking at a photo of a person. So there are various solutions that you can think of for liveness detection. Even for photos, one of the things that people are using these days are photos on a screen. It's difficult to print photos. Instead, they would just use the screen of their cell phone and show it to the camera. And the screen of a cell phone has enough information to tell you that it is a screen of a cell phone and not a real person. You can look at the texture, you can look at the glare and those kinds of things. The challenge there is to get enough data to actually do this project, if you want to do it in a data intensive way. But there are other methods, like you could have a challenge. So the algorithm challenges the user to do something. You could say blink now, and if the user blinks, then they are live, right? But you have to do a few different things. You could say blink, smile, blink, and then randomize it to some extent. It should be a combination of a few things that occur randomly, and you do that. So that would be something that can be easily done as a class project. Not a commercial grade solution, but something that you can actually do as a class project. Now, so that is, when the system challenges you, it's almost like a password. They are asking you for a password and you're doing it. The other thing could be, similar idea. It could be a blink-based password. So your password is actually your face. So you do face recognition, but that's not enough. You also need to do a series of blinks or something like that. That is your password, right? So you could be blinking, smiling, nodding your head, and that is your password. So that is something we can also do. They use, yeah. So dense optical flow is used to measure small movements of the face. Especially if you can stabilize the face somehow, you can then the nonlinear motion can be, so when you're moving the head like this, there is a linear motion you can do, even if there is no rotation translation. You could say that the majority of the movement is actually linear. So you could actually do an affine transform to get majority. And then there is some nonlinearity which you can model in many different ways. And one of them is dense optical flow. You could say that the nonlinearity would be dense optical flow, and you could do interesting things with it. Yes. So Scott, you're right. You can do those kinds of things. So once you normalize, so there are two ways of going about it, Scott. One is you assume that if you track a few points, that is sufficient to give you motion of the underlying motion. So if you're tracking, say, the eye points just like dlib, then you can say that these points are sufficient. But sometimes you want even subtle motion, in which case dense optical flow would make sense. You want to know the motion between pixels to make a judgment what's going on. Maybe when there is subtle movement in the eyes and things like that, then dense optical flow would be useful. But keep in mind that these optical flow based methods, they are very they're kind of noisy. It's difficult. They're noisy and not always, the good methods, they are somewhat expensive because optical flow needs to build this pyramid and needs to do this calculation at every pixel over the entire pyramid. So sometimes they are also slightly more expensive. So things like that, come into play when you're building real-time systems. Okay, so that was liveness detection. You can also build a simple ASL, American Sign Language based identifier. So there are two different kinds of signs in American Sign Language. And my wife actually worked on American Sign Language during her PhD. Now, there are two different kinds of signs. One is motion-based, when you sign something and the motion is what tells you what the sign is. But there is single frame signs also, where you just make some sign, like I don't know what it is, but things like some words, there is a single gesture based on fingers alone that can be a sign. So you can select 10 of those signs, maybe the numbers from 0 through 9, and then use that to, have a very simple background, have a plain background, and then your idea is to detect where the hand is, and based on that hand, the structure of the hand, you identify what gesture it is or what sign it is. And I'm pretty certain that American Sign Language databases are available, and you can use that data to train and see how it works on your own set. So that would be very, very interesting if somebody can pull it off. It's mainly, if you get the data, I think the problem is definitely solvable in 40 hours. So that was the ninth idea. One more idea that I was thinking about is you could do, for a lot of people, computer vision is used for assistive technologies. So when you want to, there are people who cannot move their neck down, quadriplegics. For them, using the face to interact with the computer, that's very essential. So there are a lot of blink-based systems which allow you to type. I cannot remember the name of the system, but there are several of them which use blink and other facial gestures to control keyboard. And one of them we had actually demoed as a user story on our blog. So a user has actually created a blink-based system. So that is also something you can try. Hi, George. So those are the 10 ideas that I thought were pretty decent and that can be done in this time frame. And if you have any ideas, if you have not submitted the project plan yet, just go ahead, and if you have new ideas you want to run by us, let us know. It would be nice to get a few more. We got about 30 project proposals, which is good enough for a competition, but 50 is even better, 100 is even better. Of course, it creates more work for us, but we still want people to participate in this project. That's the joy of creating this course, that people are actually using it to build something from scratch. So any other questions you guys have? So that's all. Those are the 10 ideas I had. I will also post them on the project page, on the page, for people to pick it up if they want. Yes, Dave, definitely. It should not be simpler than what you have already proposed. If it is slightly more complicated, that's fine. Yeah, the reason we wanted to approve the project proposal is that we don't want people to do very simple things. Um, so, but if your idea is requires more stuff, is slightly more complicated, then it's fine. Um, or it solves more interesting problems, then it's fine. Just let us know what you're trying to work on. But I mean, we are just open to whatever you have. You don't have to stick to what you had submitted. And that's also the right thing to do, because as you start working on a problem, you will notice that the idea that you previously had may not be feasible. Maybe it was not good enough. Maybe it was very easy, something like that. In those cases, feel free to come back to us and say that, okay, I want to change this in such and such way. Yeah. Yeah. And so starting Monday, our response time will also go down, because right now, we are very focused on releasing the next module. So all other things, they take lower priority. But starting Monday would be the last module. We will, the response time, we'll definitely respond within 24 hours, let's say. We'll definitely respond in a day. Okay. So is it something, Scott, are you suggesting that we have something that people can post, some kind of a forum where people can post ideas or stuff like that? Amar, actually, this is something I had thought about and I forgot to write it down. Pupil detection is amazing. I mean, so here's something that is known in psychology circles, that when you're trying to solve a difficult problem, so suppose you are looking at the person's pupil and like using a closed camera, it's completely focused on the pupil. One of the things that is guaranteed to tell you how much stress the person is, how much mental stress a person is under, is the dilation of the pupil. So suppose they are solving a math problem, then the pupil dilates much more than you're having a regular conversation. So, and one of the math problems that psychologists use is, so you take a 4-digit number, let's say 4357. So you have to add the number 3 to each of the digits. So 4357, the answer would be, 7, 6, 8. So this is, it taxes. You may think that, oh, it's not a difficult problem. It is not a difficult problem, but it engages the mind and the pupil dilates quite a bit. So if you could look at the dilation of the pupil, you can, to make the problem easier, you can also, look at light skin people, light colored, the color of the eyes are light, so light colored eyes, so that the pupil is more easy to detect. But if somebody wants to do that project where you find out the difficulty of the problem they're trying to solve by looking at the dilation of the pupil, and the baseline would be the dilation of the pupil when you're talking, regular stuff which doesn't tax the mind. That would be an amazing project also. Well, Amar, to answer your question, you have to zoom into the eyes and look at very high resolution. It can be very granular based on the resolution of the camera. And you may have some problems with dark, eyes, but with lighter eyes, you should be good. What is the, Dave, I'll come back to you. What is the deadline for submitting the final project? The deadline is October 9th, and I'm going to write this in my next email. The deadline is October 9, 2011. So you have this week, and after that, so this week, I'm assuming that people will spend to cover the material that has been published this week. And then you have one more month afterwards to finish that. There is no Slack group for the course. Um, this is something we can create if people find it useful. In my experience, a lot of times there is not enough volume, not people replying to each other, so it becomes sort of useless. But now that people are discussing projects, etc., this is something we may come up with. Let me ask this question in the next email. If a lot of people, if 30 people say that a discussion group would be useful, we'll just create a discussion group. We may not be able to monitor it actively, but we will definitely create one where people can share ideas. Yeah, any computer vision project is acceptable, George. Uh, if you're using some of the techniques that were shown in the course, that's an additional benefit. But any computer vision technique is fair game for this project. I don't know off the top of my head, MD, what is the minimum quality, but I'm assuming that uh, an HD camera should do a perfectly fine job. An HD camera should do a perfectly fine job. But the only problem is that you may not be able to come close enough to the camera without losing focus. So the cameras are designed, they are not designed for somebody to come very close. Uh, they cannot focus at that point. So for such things, you may have to have a lens or something, a different lens on top of the camera. So if you're using your cell phone, then you can buy an attachment that goes on top of the cell phone, like a magnifying glass or something, and that will help the cell phone focus. But you should try with a regular cell phone and see whether you can focus only on the eye region, whether that is sufficient. The resolution, I'm thinking that HD resolution is more than sufficient to detect that dilation. Okay, so Scott, in the past, most of the time, what I have used, I don't have to use GUI in a lot of my applications because most of the time, these whatever work we do is deployed on the server in the backend. But the one time that we used a GUI application for a client project, we used Qt for that, and Qt is a very good library. I mean, I liked it. It has a lot of GUI. I mean, whatever you want to do, you can pretty much do. You can build commercial applications using Qt. So that is what I would recommend. But of course, if you're building for a specific OS, so Qt allows you to do cross-platform development. But if you are trying to build for a specific platform, then I think you should use native libraries. Like if you're using building for Windows, then use Visual Studios and all the GUI that comes with Visual Studios. And Scott, I believe that a lot of splines, etc., they are also implemented in Qt. So that's an additional benefit. Any other questions? Scott, I don't know 100% about that. I'm not 100% sure. That would be Amar. So Amar is asking a question that can you use the gaze tracking to write the letter A? And yes, there are applications that can be, can be built. It would be very difficult to pull it off in the short time period. So can you use gaze to track the letter, draw the letter A? That's a very nice idea. I'm slightly skeptical whether you can do it in this time frame. The accuracy demands on that kind of thing is it's pretty big. Yes, George, you're right. The activation map of a convolutional layer is simply its output after the activation function has been applied. So in a regular neural network, a regular neuron, you will get only one point, and yeah, and it's also the input to the next layer. So the activation layer, a map of a single convolutional layer has many neurons, right? And those neurons are also arranged like slices. And so the activation map is the response of all those neurons in an image format, right? It's two-dimensional usually. And this also serves as the input to the next layer. Yeah, so so I'm not 100% sure that you can do it for letters. So Scott is asking, can someone use the letters? So you can display the letters on a virtual keyboard on the screen, and somebody looks at that letter, and based on that, you detect where they are looking. So letters are very dense, and it may be very difficult to pull off that kind of project in such a short period of time. However, if you have just numbers, and the person looks and they are, put on the side of the screen, the boundary of the screen, then this is a big movement, when you're looking at the edges of the screen, that is a big movement, and maybe that can be done. So yeah, in case of Scott is the question is multiple views of a 3D object, is it more efficient than using voxels? And the answer is yes, because in case of multiple views, you are actually storing the multiple views and then generating the in-between views whenever on demand. So there are those kinds of systems where you're generating an in-between view on demand. So if you create the voxel representation would require you to store the entire data in one shot. But you're also it's a trade-off between speed and memory requirement. Because once you have the voxel representation, rendering it is relatively fast. You're welcome, Amit. So George's question is, for a convolutional layer with 6 layers, I'm assuming that he's saying 6 filters. So for a convolutional layer with 6 filters, how does it work? Is the input image filtered 6 times separately and the results are added together? That's exactly right. So they are filtered separately and the results are added together. And because the GPU does this, they are all running in parallel, and you can combine the results in the end. Yes, filters, yeah. No, so in a single layer, the outputs are not connected. So in a single layer, a convolution operation is applied. A single filter is applied to the entire image, and then there is a second filter that is applied to the same image, and so on. There is no interaction between these two outputs. It is in the second layer, so all these outputs are collected as the output, after they pass through the activation function, and then they go to the next layer. But all the layer operations, they can be done in parallel by a GPU. They are not waiting on each other because each one is a separate kernel. Did I answer your question, George? Okay, cool. Cool. Yeah, I'm hoping that this, even though we had a very short period of time for explaining CNNs, and I'm hoping the material that we have published, it's good enough to get a good grasp, and then, you can go on your own to understand what's next. But at least the foundation, it gives you a foundational view. That's why we took it from a 30,000 view where you don't have to understand any math, and then try to hone down and figure out what's going inside. No, the values are not added together at all. They remain as separate layers. So the activation map the activation map for a single, so suppose there are 6 filters, and the 6 filters are applied. The activation layer would have 6 different channels. So the depth would be 6. So they don't interact with each other. George, is that clear? So you have 6 filters, and the filters are applied to the image or whatever input it was, and each filter creates one slice. Exactly. The activation map has a depth of 6. Yes. Oh, thanks, Amit. Yeah, so this week on Monday, the material we will release also have backpropagation, the explanation for backpropagation, and it's actually pretty difficult to explain something that is very mathematical in simpler terms. So we'll see how that goes. I'll still working on it. I'm trying to figure out the exact right ways. That is the last thing we are working on, but it's very mathematical. It's simple in one sense that you just need to know very simple tools. You need to know some basic calculus. You need to know the chain rule, and you just need to apply the chain rule again and again. But it can get slightly involved while explaining. It is one of those things that you have to sit down with pen and paper and work it out, and then you will see that this actually is not that difficult. But for somebody to explain, it's actually difficult because there is a lot of math involved. It's not complicated math, but it requires a lot of I, J, K kind of. There are different dimensions. A single symbol would have I, J, K kind of subscripts and superscripts. Yes, so Scott, neural networks use filters in their convolutional layers, and not all neural networks. It is the convolutional neural networks that use the convolutional kernels that we talked about. But there are regular neural networks. When you see the regular diagram, they don't need the kernels. Yeah, Dave, you're right. Very nice, George. Thanks. I did not think about it. So uh, that so the Amar, the logic behind for flipping the kernel is that most of the time these days, the kernels that we use are symmetric, so it doesn't matter whether you flip or not. If you don't flip, the operation is called correlation, and there are two. It's just, for the most part, it is just nomenclature that you know. Uh, it has to do with frequency domain. It has to do with frequency domain operation. So, okay, in case of convolution, when you flip the kernel, the frequency domain equivalent of that is that you can convert both the kernel and the image into frequency domain and then just do a multiplication operation. So a multiplication operation in the frequency domain corresponds to a convolution operation with the filter flipped in the spatial domain. So in convolution can be expensive because you're going to each pixel and doing this multiplication. But what happens in frequency domain, once you convert this image, take the fast Fourier transform of the image as well as the kernel, then it is just a pointwise multiplication. So that is very efficient. You are just doing pointwise multiplication in the frequency domain, and then you map it back to the spatial domain. So this way, you are able to do this operation really fast. And this operation, this logic holds when you're doing convolution operation. And that's why with the flipping, 180-degree flipping. So that's that. I completely agree with Amit. Andrew Ng's course is really good. I have not checked out their new courses on deeplearning.ai, but I have actually gone through the course on Coursera, and that's pretty solid. It is a theoretical course. Like, if you take that course, it doesn't mean that you will be able to build a real life deep learning application, but you will know what's inside. You will know the theoretical background for that stuff. So hyperparameters, there are there are some parameters that are obvious. For example, learning rate. If you can look at the graph and figure out, you need a slower learning rate, or you can go faster and things like that. But when we are talking about hyperparameters like the number of layers, etc., that is all trial and error. It's very difficult to come up with a formula that will work. And so what people do is people run multiple training at the same time and try to figure out what is the best hyperparameter. There is literally no magic bullet there. It's trial and error. Scott, I think I think a simple Google search. So to understand what we are going to teach in the next class on Monday, you just need to know two or three things, right? You just need to know the chain rule. That actually, you just need to know the chain rule in calculus, and that would be it. And you need to completely good. So just go to Wikipedia, understand the chain rule, and that is it. You will be good. And simple, when there are two functions, how do you take the differentiation? How do you differentiate the function? No integral required, but how do you differentiate the functions, etc. So go to Wikipedia and just check out the chain rule, and that should be enough to do this. You understand calculus for this course. So Dersu has this question: how can I track multiple, how can I track people using multiple active cameras? So it is so first of all, the cameras would need to be calibrated in some sense. You would need to know that which location in one camera belongs to which location in the other camera. So you need to know the rotation translation between cameras. And then once you are looking at a person, you know what is the prox, and it becomes slightly easier when you're looking at the ground plane. So you're looking at the camera is situated up, and then you're looking at the camera, looking at people going down. In that case, you can figure out, where is the ground plane, which point in the ground plane corresponds to which plane. So there is a very simple, when you're looking at a ground plane, then there is a very simple transformation from one camera to the other, and it's called a homography. On our website, also on learnopencv.com, I have a few examples of homography. So check out homography, which will give you the ground plane to ground plane transformation. And for that specific kind of applications, you can look, somebody is going on the ground, you can know which point it is in one camera versus the other camera. So then you can track even if it leaves one camera from to the other camera. But the other approach would be appearance based, that once it goes from one camera to the other, you want to make sure, you based on the appearance, you try to find out which person is which, or which object is which. That can be slightly challenging, especially when people are wearing uniforms where they look exactly the same from a distance. There has to be some way to tie the identities. Either it is through geometry, where you have cameras looking down at a plane, like security cameras looking down, then it becomes slightly easier. But if there is no geometry you can impose, then it has to be appearance. And in case of appearance, it is difficult if people have the same kind of appearance. For example, people are wearing uniforms, that is difficult. But if they have different appearances, then you can do some even color-based histogram matching to see whether one person moved from one camera to the other. One other challenge while doing appearance-based things is that these cameras need to be photometrically calibrated, because as you know that the cameras can look very different. The same object can look very different in different cameras. So on one camera it may look bluish, and the other camera the shirt may look slightly greenish if they are not calibrated. So those kinds of systems, you have to take into account photometric calibration or geometric calibration among them to make it work well. Okay, so next question. Yeah, Abhishek, I completely agree with you. So I'm assuming that you're at least starting with the base model and then fine-tuning it to get your final pedestrian detection. Because it always helps to start with the base model and fine-tune it. Is there any insight? So Abhishek, his question is there any insight you can draw from the activation maps? That is tough to say. We have never used the activation map to set hyperparameters. I would say that I don't know the answer. I don't know the answer. But let me ask around. Let me take this note and ask around if other people have used activation map to set hyperparameters. And for pedestrian detection, you should also look at faster RCNN is, when we tried single shot multi-box, the convergence, it took a long time to converge. We had to do a few things. I can't remember the exact details, but it took us more effort to do to train it properly. But in case of faster RCNN, it was, as advertised, it was easy to train, and it worked really well. It is slower, much slower than SSD, but still, at least from an understanding point of view, it is much easier to understand. It converges as expected. Yeah. Thanks, George. Yeah, so I mean, looking at layers, you can actually tell what the model is learning a little bit, but it's very difficult to know what hyperparameters to change the result. So visualization does help, but then how do you go and change the hyperparameters to get it working right? Thanks, Vikas. Not always, Scott. So there are, I mean, they look nonsense a lot of times, but not always. Sometimes you can actually look at the layer. So, for example, you're trying to build a card detector. In the lower layers, you can actually see the wheels. You can actually see something that looks like a wheel. So it's not complete nonsense. It's only at, when you're trying to get very low level features. At that level, it is nonsense. But when you get some high level features, then you can almost see the circle, the tires and stuff like that, the features that it's trying to detect. So we have been using internally. We have been using TensorFlow. We started with Caffe. We used Caffe for 1.5 years, 2 years, but now we have completely moved on to TensorFlow. We do have legacy code that for some clients we have to support Caffe, but now we are moving to TensorFlow, and for new clients we are doing everything in TensorFlow, and so the other option we are trying to explore is that should we use Keras? So Keras is very good when you don't need a lot of flexibility, when you're not doing any kind of research work, then you can use that. It's very good, very easy for beginners. And I would actually recommend that use Keras with TensorFlow backend. But when you start doing deeper things, then you need to be hands-on with this. You need to be hands-on with TensorFlow. Location, it's actually very difficult. Hand segmentation. You can try some skin detection based thing, but I don't know off the top of my head if there is some robust hand detector out there easily available. You can also try building your own detector based on Hog, etc. But Hog is not a very good candidate for hand detection, where the hand can take any shape. For if you want to build a hand detector, the best one would be, the easiest would be build something using skin detection and assume that the background is different for this project, for this class project. The right way to do it would be actually gather a bunch of images of different hand shapes and then use a deep learning based object detector like SSD or YOLO or faster RCNN to build that detector. So deep learning based object detectors will work. We did not cover them in this course, but if you look around, you will find these three are good choices. One is YOLO 2, single shot multibox, and finally is faster RCNN. I don't have any experience with PyTorch at all, so I would recommend TensorFlow. TensorFlow is also very well supported. They have nice features like, so the visualization support is very good. They also have good product. So not only is it good for developing things, it's also good for releasing things in production. If you want to take your model to a mobile device, it's easy. If you want to experiment with different versions of the model, they have something called I forget the name. So there are tools available in TensorFlow which make it very, very solid as a platform, not only for development but also for moving things in production. Oh, Scott asks a very interesting question. Suppose you have fixed light source. Can you use the shading information to figure out the shape of the object? So suppose you have a single colored object. Let's say it's a white object or a yellow object or something, and light's falling on it. Can you look at the shading and recover the shape of the object? There's a whole class of algorithms called shape from shading, which use this. Some of those algorithms can use a single image and recover the shape up to a scale. So, but they make very strong assumptions, and there are, it's a difficult problem. It also needs to be a single colored. However, if you go to a slightly different problem, you can say that there are three light sources. You have a colored object, and there are three light sources. So based on assuming that this object that you're looking at is Lambertian, which means that it reflects light equally in all direction, there is no specular highlight. In that case, you can actually find the surface normal by solving a very simple linear equation. Using three light sources at each point, you solve a linear system of equations, and you can find the surface normal. And so at each point in the image, you get these surface normals, and you can integrate the surface normals to recover the shape. This thing is called photometric stereo. So if you want to look at this thing, I'll just write it down. It's called photometric stereo. And the other one, yeah, so from a practical point of view, the tool that you should use is the one that is easy to develop in, so you can get a model quickly. It's also very useful when other people are using it, because a lot of models like ImageNet model, etc. So something new comes up, what are people publishing in? And that's why we stuck with Caffe for a long time, because people were using that, and it's very difficult to train your own model from scratch. So ImageNet, for example, if you train a simple classifier, 1,000 class classifier using ImageNet data from scratch, it may take you several days of training. It adds to a cost, right? Several days of GPU time is not cheap. So that you need those models to start with for fine tuning. So it's very useful when a lot of people are using the framework that you want. There's a big company like Google supporting a particular framework. That's also very useful. And then if people are releasing their solutions in the framework of your choice, it becomes much easier to try different things. So that's why we chose Caffe in the beginning, and now we are using TensorFlow for our internal projects. Okay, so if we don't have any other questions, I hope I did not miss. There were. Well, I mean, you already know the answer on how to. So Abhishek has this question. Uh, are there any pointers on how to modify or create a deep learning model for a given task? The easiest, so if you have a classification problem, just take something like GoogleNet and see if that GoogleNet model, and GoogleNet was trained for 1,000 classes, just remove the last layer and use the number of objects you want to train on, right? Let's say your training set has only 50 classes. In that case, you would change the last layer to have just 50 classes and then start with GoogleNet's model and then see whether your problem is solved or not. And in a vast majority of cases, vast majority of cases, GoogleNet would give you the best result. So it's like a very simple test that you can do. Now, if you find that there are a few different things that you can look at. For example, sometimes you don't need a deep model. When your data, you don't have enough data, it doesn't make sense to use a very deep model. Then use a simpler model that is much, so you can decide on the depth of the model depending on the complexity of your task. And also, it also depends on where you're going to deploy this model. So if you have to deploy your model on a very weak device, which is not, you don't have access to the GPU, then you're restricted by a simpler model. Otherwise, the inference time would just blow up. But it is always, if you don't have those kind of restrictions, always start with a standard network. It is very difficult to actually beat a standard network with your own architecture. And the reason is very simple. These guys work with a team of 15, 20 researchers who are very good at it, and they spend months on building one of these architectures. So if you want to, with GPU farms, right? So to beat some of these architectures, you need to be in that research domain. And because there is no easy way to say what is going to work. In deep learning, a lot of things are opaque. It's not like you have to always test whatever idea you have extensively before you conclude that your architecture is better than somebody else. So starting with somebody else's architecture like GoogleNet, ResNet, or DenseNet, now we saw very good results with this new architecture called DenseNet. You can start with that. It has, those kinds of things have huge benefits because not only do you get this architecture which has been developed by very good people working in this field, in addition, you also start with a standard model that they have trained. So you fine tune your architecture based on that. But sometimes, of course, you don't have that luxury. You don't have enough data, or your data is really simple. In that case, you can start from scratch. Like recently, we were doing a project where we are analyzing analyzing horse feces. So we are analyzing parasites and the fecal matter. So in that case, it is, the shape was the determining factor, and it didn't make sense to use a very extensive model. So we use something simpler. Mohammed, unfortunately, I have not used any of them. I've never used any of them. Don't have an opinion. Yeah, so if you're using a particular framework like TensorFlow, Scott, if you're using something like TensorFlow, then you have it available on any platform, including mobile devices. So it's always, most of these platforms are across, most of these frameworks are cross-platform. But if you're using Caffe, the original Caffe, then it may be difficult to port it to say a mobile device. But if you're using something like TensorFlow, it's very easy. Very nice, Lokesh. Thanks. I also like the name TensorFlow for Poets. Okay, so I guess that's it for this week. Next week or 2 weeks from now, we will have. So this live session was open to only people who were in the Plus, who bought the Plus section of the course. But the next one, the sixth one, would be open to everybody in the course. And we will, any questions you have related to your projects, if you're doing projects, if you have any questions related to the project, shoot me an email. It would be a larger group, and maybe we'll do it 1.5 hours instead of 1 hour. Okay, guys, thank you so much. Thanks, George. Okay, I need to sign off. Thank you.